Okay, so let's start. Hello to everybody, and thank you for coming to the last session of this TechEd. My name is Dejan Sarka, and I'm going to talk about fraud detection and how to use data mining, SQL Server data mining, and other tools for this task. This presentation is based on quite a few concrete examples. I had many projects. I put there that I'm a data scientist because this is kind of buzzword these days. Everybody wants to be a data scientist. In short, it's about programming and statistics, and I'm doing this for all of my life. I actually read in an article from Harvard Business Review, they stated that data scientist is the sexiest job of 21st century. I somehow don't believe this, I'm still doing this all of my life, and if I remember how it was when I was young, it didn't work, coming to a girl, say, hey baby, I know statistics, come on, take a walk, you weirdo. No, it didn't work this way, but anyway, they call it the sexiest job of 21st century. And I started to deal with statistics. I started to deal with statistics when I was 12 for a hobby, and then with data mining, with SPSS and other tools in early 80s. And of course, when Microsoft brought data mining in SQL 2000, and especially after 2005, after this version it is mature, then I switched to SQL Server because this is my primary tool anyway. And okay, I wrote 11 books so far, 3 courses, and let's stop talking about me and go to the essence of this presentation. So I will try first to do a little bit longer introduction to the problem, so you understand what is this about. And also to understand it is not so simple to get good results. However, it is worth investing in knowledge, worth investing in serious work, because you can quickly get very high return on investment. And then I will describe how you work on a project and show some demos. So I will describe what do you do for data preparation, how do you overview the data with SQL Server tools, and then how you mine this data with two broad categories of algorithms, directed, undirected, and explain when is which algorithm more suitable. And definitely you'll see that you learn during the development, during the project you learn, and you make multiple models, so you have to evaluate them, measure their efficiency. And finally, I will explain that, with data mining in general, and especially with fraud detection, you are not creating some kind of product. What you are creating is a learning infrastructure that people can learn all of the time and improve these algorithms, improve parameters, improve data, and then, of course, you can expect that there will be some results to harvest. So, fraud detection, what is this about? So we are searching for fraudulent transactions, for example, on online banking, or fraudulent transactions with credit card usage, or loans that might become fraudulent, and so on. So we don't know in advance which transaction is good, which is bad. So we are typically searching for those who are kind of exceptions, outliers, kind of don't fit in regular patterns. So we try to find regular patterns and then compare this with new transactions and try to realize which transaction doesn't fit to any of existing patterns, so it is kind of suspicious. There are, by the way, a couple of problems with projects for fraud detection. One of the biggest problem is that knowledge is not spreading around. Every company hides this knowledge for themselves. They don't want to speak about this. They don't let me even put them in references. I had quite a few projects and didn't get a single permission for any concrete reference. Actually, they go so far that I didn't get, for example, even permission to mention the country where the company is from. I mentioned 2 countries where I got permission to at least mention the country later. This is one of these problems, which means it's kind of hard to sell a project. You come to a company and they ask you for references. Oh, yeah, I got some references. Which are? I cannot tell you. But then people are usually reasonable because you ask them, would you let me put you as a reference? And they say, oh, yeah, you're right, probably not. So you have to create an infrastructure where you are independent from other projects, other companies, so you have to learn everything from your data. Okay? Now, next thing is, what tool do you use? You see, actually, Microsoft has strong competition in this data mining field. The strongest players in this territory are SAS, which is an independent company, and SPSS, which now belongs to IBM. And they started to deal with statistics and data mining in 50s already, so they got like 40 years or 50 years advantage compared to Microsoft. Still, the advantage on Microsoft side is the price. If you have SQL Server, if you have Office, at least standard edition, you have everything, you don't need to purchase any additional licenses. Now, first of all, online analytical processing, call-up cubes, could be also very useful. You do this analysis manually. So you try to figure out patterns manually, rules manually, and then build these rules in applications for early warnings. However, typically this doesn't give the best result. Although you can create thousands of reports in a very short time, it's still not enough. You still cannot check all possible patterns because you are limited as a human being. You cannot remember thousands of different reports. You don't even have possibility to manually create enough reports, enough combinations, and then you focus only on those where you expect some patterns, and you probably miss the most important patterns. So data mining, statistics and data mining is about analyzing data with mathematical methods, trying to find all possible patterns, evaluate those patterns mathematically to find which ones are more important and which less. And since you are excluded from this, you do not influence what kind of patterns you are searching for. This might be a problem because you are influenced by your culture, by thousands of years of development, so you automatically go to some common directions. Now, with mathematics, there is no, let's say, previous influence on this, so all patterns are evaluated, and the best are really found. And statistics might be useful if it's used in, let's say, reasonably small areas, like checking a couple of variables only. Otherwise, it can become too complicated. Data mining is based on statistics, but it's more business-oriented, and that's why this is the most suitable tool for this kind of analysis. So statistics is science, and statisticians don't care. They simply don't care what do the results mean. How do you use these results in production? And data mining is about not only calculating this, but also presenting this and making the people understand this and make these results available for production. There are 2 general data mining algorithms, 2 groups, directed and undirected, also called supervised and unsupervised. So supervised means you have a target variable, and you try to explain states of this target variable with states of input variables or values of input variables. And then you get these rules, so value of this input variable, 3, and that input variable B leads to value in target variable 2. you get these rules. So these directed models give you very, very good results, typically give you very good predictions. However, it means that you must have this target variable. So it means that there must be already some flag, for example, that flags whether a transaction is fraudulent or not from the past. If not, you can still use undirected models. It simply means you are trying to find any kind of groups of transactions and then find those transactions that do not fit well to any of the groups. Still, you get better result than by just, let's say, randomly selecting transactions to check. Still, you get some lift in this number of frauds found if you select which transactions will you check with undirected methods than if you just select them randomly. So typically, you would go in production with some directed model, like decision trees or neural network. However, later I will explain that it's always good to have also some undirected models, like clustering, for controlling the directed models. And I will explain how you do this control. Okay. So what do you do when you find the fraud? This is just a little bit from the business perspective. Blocking is typically not a good choice. Because, you see, we are talking about probability that something is a fraud or not. We are never 100% sure. Even if your mining model gives you prediction that this is a fraud with 100% probability, you shouldn't be too happy because it typically means that there is something wrong in your model. So you shouldn't just rely on these results. And you should simply still have people who are checking the transactions and deciding, maybe even calling customers and so on, and deciding which one is fraudulent and which one is not. Okay? The point is that you cannot check all of the transactions. You can have millions or billions of transactions, and you cannot have millions of people just checking this. So the point of data mining is to carefully select with some intelligence, to select which rows to check. You can check maybe, I don't know, 20,000 rows per day. You have, I don't know, 4 people. Each one has to check 5,000 transactions. So you select these 20,000 rows with data mining. Now, as I said, the best thing for the production is a learning procedure. And this is also from experience. I typically had many times problems in the beginning with customers when explaining them what we are doing. Many times people just expect this fancy application that will give you some kind of traffic lights, stop, whatever, green, yellow, red. And then I say, no, we are just building infrastructure for learning. So you will do the constant learning. Okay? And of course, it means that this work is never finished, but think of it. Why? Why must be like this? Well, first of all, fraudsters learn as well. So they improve their techniques, so you must improve your techniques. It's so simple. And you see, by selecting rows which we were checking with data mining models, you typically, as I said, get big lift from the random selection of the rows to check, big lift in number of frauds caught. However, let's say over time, this lift will go down, will drop. So it means that you have to change something. You have to relearn or learn some additional patterns, change the models. And the problem is how to detect when this is happening. You know, maybe, let's say, the number of caught frauds has dropped just because there are simply less frauds. Maybe fraudsters learned that you are good at it, so they are not attacking you anymore. So we'll have to build an infrastructure that will help us detect when it is time to refine the models. Now let's talk about this. What is an outlier? So how do we decide what is an outlier? Let's say if we have standard normal distribution, then we expect that, of course, 95% of population is around mean plus minus 2 standard deviations. Or 99 is around mean plus minus 3 standard deviations. So what does it mean? Let's say you have a continuous variable, you go 3 standard deviations away and say this is suspicious. Unfortunately, it is not that simple. Typically in business, we don't have this kind of nice standard distributions. Very typical is that distribution is skewed to the right. It has a long tail. So you see, for example, income. There are many, many people with low income, and then long, long tail, only few people, but with very high income. So you cannot just say, okay, let's go 3 standard deviations away. Maybe on the left, but not on the right side, right? Also, these distributions can also be shaped differently, more flattened, or have higher peaks. And this is so-called kurtosis that measures this peakedness. So if kurtosis is high, it means peak is high, but then also tails are very long. So it simply means that with high kurtosis, you have to go far away from the mean in both directions, not just to the right tail or left tail, before you can declare something as a fraud. So you see, we have even a problem with a single variable to say what is an outlier, right? So there, again, you see, there is no definite answer. Again, this is something you have to test and learn. And again, you have to start this doing practice from the practical perspective. You cannot invent a good measure to declare an outlier. So again, what I already mentioned, the best thing works. Select these rows, these transactions, and check them. Mark which are fraudulent, and learn, and refine the models. And you will get more and more outliers there. So at some point, you definitely realize which transaction is fraudulent. At some point, a customer will report fraud, or there will be some built-in limitations. So the first thing to do if you want to start this learning procedure is to mark this in your database. To have at least one column that is a flag, fraud, yes, no. This is the first thing. So after that, you can start this developing these directed models. And as I said, it makes also sense to check these transactions with undirected models. You also get some lift from the random checking. However, this lift is lower. In one of my examples, I got with directed models lift that was 100 times of the original transactions caught in the same amount of rows. So lift was like 10,000%, which is fantastic result. This was really great. With clustering, I got 20 times better score than with random checking. So difference between clustering and decision trees was 20 to 100. But I still insisted, let's have this clustering as well. And some of these people who are checking transactions should use clustering models. Why? Well, you see, this undirected means that you are not relying on any previous knowledge. So now imagine that this difference in efficiency between directed and undirected started to drop. Initially, it was 20 to 100. Now, let's say that this gap is starting to close. What does it mean? Well, it simply means that you can get better and better results without any previous knowledge. So it means that previous knowledge is becoming worthless. So this is the good sign that you have to refine the directed models. See? And you have the idea how you can measure the efficiency of the directed models. And I will show you later that even this is not enough, because also undirected models can become obsolete over time. Maybe there are new variables you should feed the model with. So after all, you also have to measure over time the actual number of predicted frauds and reported frauds. And you see, this measuring over time is typically done in a data warehouse. So this kind of job, like fraud detection, fits very well in the general data warehousing and OLAP system. You just add mining models as additional dimensions, and I will show you later on an example, and it's very simple then to also measure overall efficiency over time. So you have then all of the infrastructure you need. So when, let's say, the absolute efficiency of undirected models go down, it's time to refine also the undirected models. Learn new patterns. These are these two examples. I could mention at least countries, Italy and Macedonia, but I cannot mention anything else. And you see this Italian online bank had 0.7% of frauds in online banking. So what does it mean? It means that if you are checking 1% of transaction, you will get 1% of frauds if you use this random procedure, right? With selection helped by mining models, you get much better results. So you see, the hardest part here is the data overview and data preparation. Many times companies do have data warehouses, but they don't have exactly data you need for data mining. So first of all, a problem is that typically the number of frauds is very low compared to the total number of transactions. Hopefully, I mean, if this is like 50-50, it's maybe already too late to start a data mining project. And some algorithms do not work well in this scenario. So then you have to do either oversampling, which means simply copying these frauds, or undersampling, which means select less non-fraudulent rows for feeding the models. And I am a big fan of undersampling. Why? Well, first of all, you see, typically you have millions of transactions, but in order to make an efficient model, data mining model, you don't need millions of rows. This is based on statistical sampling. See? You need 20,000, 50,000 rows. You don't need billions and billions of rows. So you can select, you can do undersampling, you can randomly select non-fraudulent transactions and then start building the model. Works much better than by copying the fraudulent transactions. This is over the top from experience. Decision trees algorithm is very good one, very popular, also because it's very easy to understand, and works with nearly any kind of, let's say, percentage of target state. Naive Bayes is very fast and simple algorithm, but when there is less than 10% of the target state of fraudulent transactions in your dataset, the results tend to get much worse. Neural network, another directed algorithm, works well only when this is about equal percentage of target state and other states. See? So next thing is, first, as I said, you have to do carefully the sampling. And by the way, this is very important. I've seen many times questions like this: how can I optimize my data mining model? I'm feeding it with 10 million of rows, and it's calculating, working all of the weekend. So how do we optimize data mining models? The answer is correct, we don't. See, there is no such thing. These algorithms scan the data multiple times in multiple iterations. No indexing can help you. So what you do is correct sampling. This is, let's say, optimization if you want. But you don't do this because of physical optimization. You do this because from statistics we know that with larger samples you simply don't get better results. Makes no sense. Next thing is, you see, basic variables are typically not enough. It makes sense to add a lot of derived variables, and for this you definitely need a subject matter expert as a part of the project. So these are kind of variables that worked very well. For example, with this Italian online banking, we made derived variables where we flagged whether multiple transactions are coming from same person, but from different IP addresses. We got username and we got IP address in a specific time window. So let's say if somebody makes 10 transactions in a single day from 5 different IP addresses, this flag was turned on. And what is the number of different IP addresses and what is the time window? Again, something you don't know, something you have to test. The opposite, transactions from multiple people, multiple users, the same IP, this didn't work well. Turned out that these are mostly companies and families, so everything is fine. Also, this worked very well. Is the amount on the transaction close to some limit? Not exactly the limit. You see, fraudsters have learned this. So they don't go exactly to the limit, but they go as high as possible. So you group these transactions in groups and say, close to the limit, far away from the limit. And again, where is this boundary between close to the limit, far away from the limit? I don't know, you have to test. Time of a day also made some difference. I don't know why, but still this is kind of old people's habit. You know, thieves work over the night. And also it's interesting, also fraudsters prefer night. It's like old, you see, these old patterns we have built in. What does it make a difference in online banking, for example, whether it is night or day? But, you know, from people's behavior, it makes a difference. This is very, very interesting. Anyway, you see, all of these variables you create are also very useful for other reporting and online analytical processing. So this kind of project is a very high-end project. However, it has many positive side effects. Also improved OLAP cubes, also improved reports. Very nice. Now, data overview. You see, SQL Server has nearly all of the tools you need for a successful fraud detection, except for the data overview part. So, you know, there are not many statistical procedures built in. There is, at least I don't know, for a tool in this SQL Server suite or with Excel that would enable you with very, very quick graphing. And what do I mean by very, very quick graphing? You see, in such a project, you typically deal with hundreds of variables. So I cannot go to Excel and create a graph manually. I want a tool that I simply list the variables and I get graphs of distribution. However, there is no such thing in Microsoft, so you have to create your own way to do this. And this is where statistics come in place. Descriptive statistics. It's called descriptive statistics because it describes the distribution. Okay? It describes the shape with numbers. And this way you can get the impression very quickly. However, you need to understand the statistics. See? And you should use any tool. Any knowledge you got is very useful. You see, I use OLAP cubes for a quick overview of distribution of discrete variables. How? Extremely simple. You just put a measure count. And then you get distribution. And I will show you this on an example. And I will switch to demo in a minute. So, statistics. I mentioned statistics. But what we got is this aggregate functions like sum, average, standard deviation, variance. And this is more or less it. So, no other way than writing your own procedures. Actually, you don't need to write all of them because I wrote many of them already, and they are in many places, in books and in downloads. But you see, I enriched SQL Server with CLR procedures, prepared all kinds of queries in stored procedures, so I can quickly calculate quite complex statistics and find out find data distribution, find whatever I need in this data. Okay? Nevertheless, if there is some third-party tool already in place, it might be very useful to use it. So let me switch to the demo, and I will just show you a couple of queries. And I hope you can see. Can you all see the code? Yes? Okay. So, for example, distribution of a discrete variable. Typically, frequencies distribution, this is very standard way of representing is absolute frequency, cumulative frequency, absolute percentage, cumulative percentage, and histogram. And there is no such thing out of the box in SQL Server. However, you see this nice little query does exactly this. Does exactly this, and is, by the way, very efficient. Actually, you see, I'm developing this kind of queries for me from 2000, from the first data mining in SQL Server. And this is version 2012. This kind of query was much less efficient in previous versions. Now, with new window functions, this query actually works with a single pass through the data. And I'm talking now about fraud detection, so I'm not going into details of Transact SQL. But it's a very nice query, and I uploaded all of the code, so you will be able to download it and analyze it and see how it works. Anyway, as I said, you get these nice results. You can even create a stored procedure, and this make this query dynamic and parameterize table name, column name, and you can get very quickly distribution of discrete variables. Okay? Of course, this is not enough, so you also want to make pivoting, or let's say, in statistics, we many times call these contingency tables. Find distribution in groups of two variables. This gives you an impression if these two variables are somehow correlated. So you see, if you have, this is also very important, if you have like 500 input variables, you want to focus on those who have the most influence. So it's good to get this impression in advance. Unfortunately, there is nearly nothing in SQL Server that would help us do this. So, like, you know, this pivot operator is very clumsy, more or less useless, right? Yes, right. But what you have other tools. You see, you have all-up cubes. And I developed a project here. And let me show you. So I'm using, of course, I cannot get some real data. My customers would kill me immediately. No way, sue me immediately. So I'm using AdventureWorks DW with target mail view, which has some demographics and some flag that says whether this person is bike buyer or not. And we'll pretend that this is a flag, whether this is a fraud or not. Okay? So I actually created all-up cube on a single view and used it for measures and as a dimension, right? And you see I have only two measures, this flag, bike buyer, and number of cases, which has a simple aggregate function count, right? And then I have this demographics data here in other attributes. And yes, maybe you notice this squiggling blue line here. This is telling me something that this is not in accordance with best practices, but I'm not building an OLAP cube. So this is perfect for my needs. So I will not follow best practices in OLAP at this moment, right? Once I've got this, I can use browser and do all of these overviews very, very quickly. So for example, you see number of cases, demographics, let's say occupation, and I got my first my first distribution. Or if you go to Excel, then of course Excel as a client, you can create nice graphs, you can create nice pivot tables, and you can change this with a single click. So for example, if I don't need marital status, I will uncheck marital status, put gender here, and I have pivoting over gender and distribution of a single variable. So with one click, I can do anything I want. And by the way, with Power Pivot for Excel, you don't even need analysis services for this. You can do this directly on the client side and create a Power Pivot model. And this is very useful if you have some advanced analytical people who are already using Excel. Actually, you see, I had a customer, which I cannot mention even a country, right? But they are actually developing a central fraud detection system using some custom application built over SAS. And they have many subsidiaries in different countries, and with some larger subsidiaries, they have local analytical people. And they wanted to speed up the learning of new patterns. You see, if you do everything from one central source and then spreading this around, the whole process of learning is very slow. And they had these people who used Excel, and we simply went to subsidiaries, introduced Power Pivot, introduced data mining add-ins, and started to do small fraud detection project locally. And then they simply reported patterns found and enriched the main system. And this is very useful, and there was no competitor's tool that would be able to do this, especially without any additional investigation. Okay, next, how about, let's say, continuous variables? Well, I created skewness and kurtosis user-defined aggregations. And again, I will not go into details of this code, but again, it's quite efficient. It needs only one pass through the data, and it can calculate this with the same efficiency as sum or average built-in aggregate functions. You just need to enable CLR, deploy the assembly, which means load it in the database, and then create these aggregate functions. And after that, you use them like you use average and standard deviation. So for income, let's check. We have some skewness. Of course, it has some long tail. We have also some kurtosis, so it means it has some long tail also on the right, on the left side. Where does this long tail come from? This is demo data. It's very hard to make good demo data. Or maybe, I don't know if this is income. if you consider all of these Southern European countries, I'm from one of those as well, Portugal, Spain, Slovenia, Croatia, Italy, Greece, maybe it's already income below zero somewhere. Maybe we are already there, so this is where this tale comes from. And of course, you can even do this in groups and check this in groups. So you can see that, for example, with 4 cars, we have actually negative skewness, which means that demo data is not good. The demo data distribution is not good. 4 cars mean reach should be long tail there on the right side, right? Anyway, this is what we got for demo. So demo data, so we have to play with it. Okay. As I said, there are many, many additional things you need to do, you need to check. And I cannot go in all of the details. The problem is, how long do you do this? I mean, how many things do you check? You see, this is another big problem. You try to create a derived variable, it doesn't give any result. You create another, gives some result. Then you stop. Maybe if you would create just a single one more, you would get better result. So how do you know when it's time to stop? Well, simply, I try to deal about time spent, price in advance with the customer. So let's start always with a proof of concept project. And this should be short, maximally 10 working days. I'm not saying 10 man days, because multiple people should be in the team. However, from 5 to 10. And then you simply say, okay, 70% of the time we deal with data preparation and data overview. That's it. As I said, maybe if you would spend 5 more minutes, you could get better result. I don't know. I cannot guarantee that we will find the best model. But remember again, we are building a learning infrastructure, which means the customer will be able to refine the model and find better and better models over time. So this learning infrastructure is useful not only for finding the point when you need to refine the models, but also to test, and you see the results, and improve over time. Then you have these data sets prepared. And then we have again this problem. We can build multiple models using different algorithms and then using different algorithm parameters. And we build as many models as we can. How many? As many as your time allows you. So I would say spend like 20% of the time in this, building the models. Evaluating is fast. Okay? Maybe the next model you would create would give better result. I don't know. But again, we have this infrastructure, so the customer can independently from the consultant refine these models, adapt them, and make them better and better. Now, you see, measuring efficiency of directed models is really simple. Very nice idea. You simply split your data set in training and test set. 70%, 30%, this is rule of thumb from experience, works the best. And you train the model on this 70% of the data, and then you try to predict the frauds on the rest, on the 30% of data which is in the test set. However, because this is known data, you already have the result there. And you can simply measure how many times the predictions was correct. And there are even standard ways how to present this. I will show you later. Lift chart is a very nice way where you can very, very quickly see which model is the most efficient. There are also some other techniques. Cross-validation could be also useful for validating directed models. Cross-validation means that you create many subsets of data, like you split data in 10 folds, training data, the 70%. And so this is kind of additional checking inside the training set. And then you just say, my first 10% is test, and 90%, other 9 groups are training, and see how many correct predictions are there. Then you say, my second fold, my second 10% is test set, and you repeat the procedure. And then you measure the average number of correct predictions and the standard deviation. If deviation is high, it simply means that with small changes in data, your model can become very unstable and gives not so good predictions anymore. So maybe you even decide to deploy a little bit more robust model, even if it doesn't give you the best overall predictions. Also, some algorithms are also useful for evaluating other algorithms. You see, decision trees many times gives you the best results, but I also want to check the same data with naive Bayes. The way how decision tree algorithm work is that it splits data using input variables and measures the frequency of the target state in these sub-branches. And it splits it in this way that it gets purer and purer branches in terms of target variable. So it means in one branch mostly frauds, in other branch mostly non-frauds. And then it repeats this procedure. So what happens if two variables are highly correlated? You see, first split, one variable will be taken, and the second variable will not be taken anymore in the next split, because there will be no gain. Because the variables are correlated, so there will be no gain from the target variable point of view. So for example, typical is education, occupation. And then you might think that one of these variables is not important. Naive Bayes, on the other hand, is much simpler. It's called naive because it treats every single input variable independently and just measure the efficiency on the target variable for every single input variable. So it will not throw away, let's say, education if it already used occupation. So just not to miss some important variable in further data preparation. This is what we already said. How many models? As many as you can in this limited time, right? And how many cases? Statistical sampling, you never need more than 100,000 cases. And forget about big data and so on. This is statistics, okay? So let me go and show you in a project how these things work. So I have some already prepared directed models, so I will just show you the results. So for example, this is decision trees, and I'm using target state 1. This is what interests me. Let's say that these are frauds. And darker color means more target state in that box. So I can see easily see, you see this very nice presentation and very easy to understand. How do you get there? So let me open the mining legend. Let me open it here. And you see, with number of cars equal 1, age between 46 and 53, and one child, and commute distance 0 to 1, we have nearly 90% of bike buyers, okay, but we pretend frauds. Okay. So these are these nice rules, and you can also see from this viewer why you can understand why decision trees is so popular algorithm. Gives good results, and it's very simple to understand. As I said, not all statistics is useful for business because it's simply impossible to understand what you get. You know, maybe principal component analysis. It's very popular trying to group, let's say, or regroup variables, columns, in new factors. And get the mixture of these new factors. Let's say you have 10 input variables, so it creates 10 new derived variables, this principal component analysis, in such a way that, let's say, you have 90% of variability in first two variables. So this would be a nice way to limit the number of input variables for decision trees, for example. Take only these first two factors. Yes, but it simply doesn't work in business because you cannot interpret, it's very hard to interpret what exactly these two factors mean. It's not so understandable, so it's not so popular. I'm not saying it's useless, but it's harder to understand. And, you know, you deal with managers which typically, you know, don't know a lot about statistics, so you cannot use it. Dependency network viewer gives me overall impression. So you see number of cars owned has the maximum influence, and then age, and then region, and so on. And this already gives you some results. Fine. Let me show you some other model. For example, naive And let's check dependency network for naive And it's pretty much different, right? And I'm not going into details what exactly does it mean, but it's pretty much different, which simply means that it's useful to check whether decision trees maybe skipped some of these important attributes because they are correlated. And actually what I did here is another way how to check correlation of discrete variables. Another way. Very efficient way, much more efficient than doing this manually as I did previously through OLAP and Excel. How did I do this magic? So what I see here is the gender is not connected with anything, and there is, let's say, strong connection between marital status and number cars owned, which is kind of logical. If you are alone, probably you don't need so many cars. And you see even direction. Total children has influence on marital status. Okay, this is, again, demo data, and interpretation is up to you. With naive you can also measure the direction, but you must use your common knowledge. And probably the direction is the opposite. Probably marital status has some influence on total children. Or not, who knows? I mean, maybe people just start sex first and then marry when it's needed. Maybe we have just proven this. And how did I do this? If I go to this mining model, you see every attribute can be either, I have these states here, input, predict only, or predict. Predict only means just for prediction. Predict means that every single attribute here is all input and predictable. So I'm actually creating multiple naive networks. And this viewer is very nice because it shows me all of the results at the same time. So I can quickly see which attributes are correlated and which not. Now, let me go to the mining to the leaf chart. You see, when you build the models, you should already put some test set aside. You can do this in the data preparation part. However, analysis services can do this for you. It's very simple. It's just one property. So let me see here. Properties of this mining structure. You see, this is this property. Hold out max %, 30. It means it selected analysis services automatically selected 30% of rows randomly, put them aside for the test set, so I can check the efficiency of the predictions. So I will go to mining accuracy chart, and I'm interested in predicting value 1 and compare decision trees, naive Bayes, and neural network. And I'm using this mining model test cases, these cases which were put aside automatically. And you see, this is the lift chart, very efficient way to show the efficiency of the models. So we have 3 models plus 2 additional lines. Apparently, in my data set is around nearly 50% of bike buyers. Okay? So the topmost line is called ideal model line. So ideally, if I could predict with 100% probability who is bike buyer or which transaction is fraudulent, I would need only 48 or something % of cases to get 100% of frauds. The lowest line is the random model line or random guess line. It means if I have around half of the frauds. So if I take, let's say, 60% of cases randomly, I will get 60% of frauds. And the other 3 are from the model. And this is where you can see this lift graphically. This is why it is called lift chart. So you can see the lift graphically. And from the legend, you can see that we get the highest lift from the decision trees model. I know from the name TMDT. And neo-Bayes is the least efficient. And neural network is somewhere in between in this case. So, okay, I would maybe even test cross-validation. I will not do this because it's possible to do it automatically. There is cross-validation tab. But remember what we are doing. We are creating tens of different models, so it would simply take some time. And the conference is over in 20 minutes. So let's skip this. But just from this lift chart, I would say, okay, decision trees is the one I will put in the production. So let me switch back here. Undirected models, clustering is very useful. Microsoft Clustering has actually 2 algorithms built inside, K-means and expectation maximization. K-means is useless for fraud detection for this, because K-means assigns each case to exactly one cluster with 100% probability. Expectation maximization assigns every case to every cluster with some probability. So for example, case 3 belongs to cluster 2 with probability 0.8 and to cluster 4 with probability 0.0001 and so on. And I don't know, case 17, the closest cluster is cluster 10. However, the probability is, because it's already, let's say, 3 standard deviations away from the center of the cluster, it's already 0.1, 0.05. Right? So the highest, and the probability for other clusters is much lower. So the highest probability is low, which simply means this case doesn't fit into any of the clusters. So this is my outlier. And by the way, this is another side effect from this, positive side effect. In general, when you do any business intelligence project, a side effect is typically improved data quality, because you see all of these areas of bad data. However, you see, some errors are very hard to find, because this is maybe just weird combination. You know, every single variable has a valid value. However, the combination is weird. Well, you do the clustering, and then you find those rows that do not fit into any of the clusters. And you can find also this kind of errors, this kind of high-end data quality exceptions. And this is also available in Excel. So your advanced IT or analytical people can even check data quality directly from Excel. Very simple to use, and I will show this also later. Now, then how many clusters are you searching for? 3, 5, 10? Again, we are in this problem. I don't know. So you create multiple models, and then you measure the efficiency of the models. However, you see, measuring the efficiency of clustering models is not simple. There is nearly nothing out of the box that would help us. And I developed my own procedure, and this is quite complex. You see, the idea here is that there must be a lot of homogeneity inside clusters and a lot of diversity between clusters. Why am I complicating? Why do I search for the best model? Well, if you are doing a big project, again, you have to deal with millions of transactions. So I really want to find the model that fits the data the best. So it will give me the least amount of frauds, of suspicious rows. You see? Let's say that you have to check 100 million of rows, and you focus them on 1 million of rows. You didn't do anything. They cannot check them. So I want to get as good coverage of the data with clusters as possible. And I'm not really interested what do these clusters mean. You know, clustering was created from another perspective, just to try whether there are some, let's say, groups of your customers, and then read the clusters and get the understanding what these groups mean. I'm not interested what this group means. I simply create multiple models and check which one is the best, and that's it. I'm not interested in the business content here. And you see, you can measure homogeneity inside clusters with entropy from information theory. So you can calculate entropy inside clusters, average entropy over all clusters, and then compare this average with, between multiple clusters. And you see which model gives you the most homogeneous clusters. So it's not really simple. So you see, I created here also a couple of clustering models. I actually have 3 with different algorithm parameters. So for example, this one has 10 clusters, right? And this one is TMCL5, means it has 5 clusters. This will search for number of clusters automatically. If you put this target value to 0, then it means try to find automatically these clusters. Now, if you want to understand something about your customers, you go to this cluster viewer and check, okay, so let's check marital status, okay, married people are typically in cluster 5 and so on. And you check cluster profiles, so you can see that, I don't know, let's see, one interesting variable for this, house owner flag, 1. So in cluster 5, we have mostly house owners. And then you get understanding what do these clusters mean. And if you are doing this for customer relationship management, you should definitely do this overview and use the model that gives you the most information from business perspective. But here, as I said, I'm not interested in this at all. So all I want to do is some, again, advanced querying and simply evaluate these clusters. Sorry, it already exists. Okay? Evaluate these clusters using different methods. So there is some score inside each model. Oh, by the way, why I'm doing this with linked analysis services, I'm reading the content of the model with DMX queries from analysis services. Okay? This is how it works. However, DMX is very simple language. It doesn't have all of the expressions. I need to evaluate them. I cannot calculate entropy and so on with DMX. So that's why I'm using linked server. And then from SQL Server, I sent DMX queries to get the analysis services data, to get this content of these models. And then I can calculate things with Transact SQL. So internal score gives me the result that 10 clusters is the best. Now, there are other possibilities. So, for example, there is DMX cluster probability function that gives me exactly the highest probability for the closest cluster. So, if clusters are homogeneous, the average of this probability must be high. So this is the idea here. Now, I need to assign cluster membership to every single case. And you assign this with DMX prediction join. So this query is very twisted. So what I'm doing here, I'm sending transact SQL, open query, which sends DMX to analysis services, which has internal, look at this second open query. This is DMX open query, which goes back to SQL Server to assign the cluster to the source data. And I was really afraid when I tried this. I was afraid that I would come to some endless loop, but it works perfectly. It works perfectly. So it's kind of very, very twisted query. And you will also see pretty long. It compares these three models using average cluster probability. And you can see that this has some price, going there and so on. However, in this case, it evaluates this model, automatic model, that was the best. And finally, this is what really works nice. Average entropy. Which measure is the best? Based on my experience, this average entropy works the best. Lower entropy means more homogeneous clusters. Why it works the best? Because this measure entropy was developed exactly for this task, to measure the homogeneity of the population. So in this case, again, I see that the model with 10 clusters performs the best. And this is the one I would put in production. Now, the vast majority of the work is done. Time to harvest the results. We already did some of these things. So how do you make predictions? Connect to analysis services, send DMX queries, and you can do this from your application. Or you can just use mining viewers. These mining viewers are also available in Excel. See? And they are also available for you. I mean, these are just .NET libraries for Windows and web clients, so you can even include them in your own applications. Or just send DMX queries for this kind of traffic lights warnings, suspicious transaction. Right? As I mentioned, we got very, very good result in one case. Also in other cases, reasonably good. However, be prepared on surprises and please use common sense. Two good results mean something is wrong. Especially, I didn't go in details of decision trees. But decision trees, how the algorithm works, kind of tries to please you. Many times decision trees actually give two good results. See? So you should be careful and use domain knowledge. Say, no, this is not possible. I cannot be that good. No way. See? However, okay, this means that you need subject matter expert. You cannot work by yourself. Now we already have infrastructure to measure the efficiency of decision trees, but we also need to measure overall the efficiency. So next step is put everything in an OLAP cube. That's it. And if there is a data warehousing and OLAP system in place, fine, you just enrich it. If not, you can quickly create a very simple one, add the time dimension, and measure the efficiency over time. Create detail packages and measure the efficiency over time. So what you got is this. You flag reported frauds, and then create directed models to learn on this previous knowledge, and then use them to predict on new data. And then, of course, you use clustering or undirected models on the rest of data that was not used for directed models. Have people that use clustering to select rows. This is the control group. And you check whether the difference in lift between directed and undirected models is dropping. And of course, we need to check also clustering over time. And this is simply another check, another control group, simply going directly to OLAP cube to measure overall efficiency. And no matter which result tells you that you need something to change, Maybe the efficiency of directed models has dropped. Maybe the efficiency of undirected. Anyway, you simply refine the models. Or you even use this infrastructure to try to find better models. Try to change something and see the results. You have the infrastructure. With next OLAP cube load, you will already see something. Of course, probably you would use multiple time points to be sure, but you can learn. So let me show you an example. And in this case, I actually created an Excel mini cube. So I'm using, you see, customers, products, sales, dates dimension, and I added as a dimension mining model. And this is in Power Pivot instead of analysis services, just to show you how you can also use Power Pivot. There is one simple trick. If you try to load data in Power Pivot from analysis services, I will not load anything just to show you this. Whatever. It gives you the MDX editor, MDX designer, MDX editor. There is no DMX editor. However, this window actually, if you go to designer, is MDX, as I said. However, this window actually accepts DMX query. Let me go to the data view, and this is this table. And let me show you the query table properties. So this is actually a DMX query. You simply have to write DMX query in the MDX query editor. Don't use graphical editor. Write this in Management Studio and then copy paste here. And I'm getting the content of the mining model in my Power Pivot database. And since I have all of the infrastructure, I can measure the efficiency of the models over time. So you see I have time here, and I measure one model, in this case decision trees. But since this is complete OLAP, I can even check how efficient it is in different groups. So for example, I'm using income group here, and you see that this model was very efficient for high income group, always. However, apparently, we learned something in June for moderate and low income groups, and the predictions became better. And this is just OLAP, as we saw. So I can, with a single click, what was it? Customers. Okay. No, the customers. So instead of income group, I can check over house owner flag, like this. And see, of course, similar results for people without house. They typically have low income. Apparently, the predictions were not so good in the past. But you understand what I'm talking? I have the complete infrastructure for constant learning. And this was the goal. And this works in Excel. By the way, you can also do data mining in Excel with data mining add-ins. And here I got, like, just for the last demo, because we are coming to the end of the data time. So this is already the result of clustering for data quality. So I selected 75 rows, which are the most suspicious automatically, by using clustering algorithm to highlight exceptions. And this is what data mining add-ins allow you to do. However, please note the distinction. Power Pivot is an add-in where Excel is independent from analysis services. It is actually a single user analysis services. Data mining add-ins don't bring data mining engine to Excel. You need analysis services in multidimensional and data mining mode installed, and connection to this. So Excel sends data to analysis services creates the model, and then Excel sends DMX queries to show you this. So, since we are close to the end, I will finish here. You see, this is the infrastructure. This is what I intended to do. Are there any questions? Good. Okay, this makes no sense, related content, and find me later at airport and so on. This makes no context, no sense in the last presentation. Okay, resources, this is recorded, will be available on channel 9 and so on. And please, I know it's Friday, I know the conference is over, but please take some time to evaluate this session. And thank you very much for being here, for staying with me so late, and enjoy the weekend if you are staying here, or safe trip home. Thank you.